And we are live. Hello, everyone, and welcome to another Circuit Stream workshop. Super excited to have you all here today. I do see there's a lot of you who have joined us currently, still waiting on some more to join us. But before I get going, I do want to make sure that you can all hear me and see me. So in the chat box to the right, can you please let me know if you can hear me and see me? I would hate to continue on without anyone hearing me. Adriana, great to see you. Yes, we can. Kyle, Ulrich, Jean, Maggie, Paul, Jessica, Victor, Farzana, and Raj, thank you so much for letting me know. Super happy to have you all with us again. I do see a lot of familiar faces here. I did some research on VFX yesterday, and I do say this with all of our workshops, that they're super exciting. But this one is a really cool one, and it's going to be super fun to be hosting it alongside my colleague Tyrell here. Now, as always, a couple of housekeeping items that I'd like to let you all know. So as you've seen to the right there is a chat. So feel free to chat amongst yourselves, toss in your LinkedIn profiles, comment on anything you'd like. But if you do have any questions for our team to answer, whether it's for myself or Tyrell, my colleague Kyle backstage, Dayon, or some of our other instructors and developers, there is a questions tab right beside the chat tab. So in the questions tab, toss those questions inside there. It helps us really organize them, see what we haven't answered, what's left outstanding. We do have an in-depth Q&A session at the very end of this workshop. So we'll cover all the ones that we couldn't get through throughout the workshop and any technical ones that I myself won't be able to speak too much to. Now, beside the questions tab, there is also a polls tab. So throughout this workshop, I'll be tossing in polls to gauge the experience of the audience. And for instance, I'm going to toss in a poll right now just so you can see what that looks like. This poll is asking, what industry are you interested in or potentially working in currently? So I'm going to add a poll, and let me just go back here and publish the poll. So the poll is now added in the polls tab. Let me know, get familiar with the polls tab. What industry are you currently working in, or are you interested in potentially applying VFX to, or working with AR, VR, and Unity? Lots of, a couple of gaming, film, education, design. So it looks like some of you have found that polls tab. Wonderful. Now, before I continue on with the introductions, who we are and what we do here at Circus Stream, I would love to introduce you all to VFX with a cool video that I found online. Now I'm going to drop this video in. It's about a minute long, a minute or so, 45 seconds, let's say, a very brief intro to what Vfx Graph is in Unity. And then I'll throw in some other videos really to help you get familiar with it. Tyrell will come in and really show you how to get started with a Unity project and applying a lot of these VFX stuff. So as I'm finding the video here, I'm going to toss it in. It's about 46, 45 seconds long. So here it goes, and I hope you all enjoy it.
The Visual Effect Graph is a powerful tool to create stunning visuals in your Unity projects. Inspired by leading software from the field of film visual effects, the Visual Effect Graph adapts many of the same powerful features for the creation of real-time visual effects. In this video, we're going to compare the Visual Effect Graph to the existing particle system and demonstrate the advantages of GPU-simulated particles. We will also provide you with some use case examples and let you know how to get started with this powerful new tool. Intended for everyone from VFX newcomers to experienced VFX artists and programmers, Unity's Graph View uses nodes and blocks to provide an intuitive workflow that's quick to learn, yet powerful when mastered.
Beauty. So that's just a little quick, brief introduction about VFX Graph and Unity. Obviously, we'll dive into it a little bit more. But with that, I will lay out the agenda, share another video, and get going with the introductions and invite Tyrell here in about 10-15 minutes. So again, this intro will take about 10 minutes long. Then we'll invite my colleague onto the stage here to handle VFX Graphs, doing a deep dive into it. That's going to take about 30 to 45 minutes or so. Then Tyrell will hop off, I'll hop back on, wrap things up and offer some resources for you all. That'll take about 5-10 minutes. And then any questions that we have in the questions tab that we haven't answered, we'll get through at the very end in that Q&A session. It'll take about 15 to 30 minutes, depending on the questions we have. Now, This workshop is recorded and it will be sent to all of you who had registered. All of the project files that we'll be using, whatever Tyrell will be putting together, all of these files and resources will be emailed to you when the workshop wraps up. So for those of you located abroad, in Europe, Asia, if it's too late or too early for you in the morning, don't worry about it. You will receive the recording and all the files associated to this presentation here. But with that, I will share another demo video of Unity VFX Graph. Now, I'm going to share this. This one's going to be closer to a minute long, but I want you to take a look at the sparks and the smoke that's coming along and all these little things that really kind of highlight VFX. So I'm going to toss it in right here. It's going to be about a minute long, and I'll come back to start the intro and get going with you all.
Hello, Baker. Can you hear me? I hope you made it safely down there, and I hope you can hear me. I can't hear anything. The whole system's busted. There you are. I see you in the monitor now.
Security check in progress.
Good to see you well.
Access granted.
And there it is. You've been granted access to continue on with the workshop here. Hope you guys enjoyed that one. Oh, it gives me the shakes whenever I watch it. But with that, let's get going with the presentation. My name is Stefan. I'm part of the education team here at Circus Stream. I myself have over 7 years of experience in the tech industry, working with travel IT companies, learning management system providers, ERP and business integration platforms, and now in the beautiful world of virtual reality and augmented reality. And then as David had mentioned in the chat here, he's seen a lot of our workshops. Little icebreaker fact about myself, I was a member of Water Polo Canada and trained with the 2008 Beijing Olympic team. Didn't go to the Olympics, but great experience nonetheless. Now, with that, it's a pleasure to have Tyrell join us today as well. He will be leading more of that technical and theoretical portion about VFX graphs in about 5-10 minutes here. Tyrell is a lead instructor here at Circus Stream. He's also a CTO and co-founder of his company, Elucity. So feel free to check that out if you have any curiosity about what he's doing there. Tyrell comes in with over 6 years of experience on the development side of things, over 4 years of experience as a tech artist in AAA gaming. And Tyrell, a 6'8" former NCAA basketball player who can solve a Rubik's Cube in about 21 seconds, which blows me out of the water. Probably takes me an hour or two, if that, to solve a Rubik's Cube. Now, a little bit more about Circus Stream. So who are we? What do we do? Well, Circus Stream was started in 2015 when everyone was really looking to get started with creating content and be the first studio out there. We saw a gap in actually helping people learn how to develop, manage, and implement VR and AR experiences. And since 2015, we've been holding various live and online courses, have trained over 30,000 people how to develop and manage their own virtual reality and augmented reality projects. We're a team of about 20 located all over the world, mainly in North America and South America. But you can find us everywhere, really, as you can see on the map here. Now, Circus Stream is a Unity certified training partner, and training partners are approved based on their expertise, focus on quality education, and commitment to providing the highest level of training available. Now, there's one really big part of our business here at Circus Stream, and it's education and training, teaching people and helping them learn how to build VR and AR projects. And these are just some of the companies and people that we've had join us to learn more about this, create their own projects, or bring it back to work. From Microsoft to Anglo American, Dell, Accenture, Koch Industries, various universities and colleges out there, to Tesla. You name it, we've had the pleasure to have them with us and to help them learn about all of this. Now, how do we do this? Well, we offer a breadth of different courses, a variety of different courses and workshops. And the two main ones that we have is our beginner-friendly XR Development with Unity course, as well as our more advanced, quote-unquote, XR Project Accelerator program. Now, both of these are all live and online, project-based, where we help you kick something off and develop alongside you. So if you're ever interested in that, check it out. I'll talk more about it at the end of this presentation. Now, with those two courses and what really differentiates us from, let's say, Coursera or a lot of these other educational providers out there, it's the one-on-one support and mentorship, where we meet with each student privately each week to support them on their ideas and projects and develop those ideas alongside them. Now, in addition to these two larger courses that we have a couple of shorter courses from C# scripting, that's what Unity uses, to XR design courses. So really to either complement what you've currently been learning in VR and AR, or to get started with in terms of C# and Unity if you're completely new to this or haven't touched C# in a while. Now, another cool thing is that we also do some content creation work and consultation with different companies around the world. And these are some of the ones that we're currently working with and consulting with to help them implement and manage VR and AR projects. So all of our instructors are current VR, AR developers working with companies like these. So everything that you're going to learn on this workshop today and potentially in future workshops and courses, it's all up-to-date, relevant material applicable to today's work. Well, now that you've learned about us, what are you going to learn here today? Well, today we'll be showing you what is Unity Vfx Graph. Then we'll go into how to quickly use VFX graphs in your projects, how to polish and upgrade your XR experiences using VFX Graph, how to create storm effects using particle systems, and effective workflows of using visual effects from an expert XR designer. Now, I'm going to toss in a poll here, as with all of our workshops and webinars, but I'm curious to know, how much Unity experience do you have on a scale of 0 to 10? 0 being, I've never heard of Unity before. 10 being, I'm the Chuck Norris of Unity, a Jedi Master. Let me know how much experience you have with Unity. Again, 0, never heard of it. 10, you're a legend in Unity. So just based off of the results there, looks like we have quite a few beginners and then some more advanced people as well here, which is great. Love to see the audience. Oh, actually, I'm actually wrong. It's about mid-level. So some beginners, some more advanced learners. So it's a mix in the audience here today. But for those of you who are new to Unity, what is Unity? Well, Unity is a free 3D development engine for building games, simulations, and experiences. It's the easiest way to begin making apps for XR. And XR is the umbrella term for augmented reality and virtual reality. XR stands for extended reality, which really just captures the industry as a whole and in general. And how does one person actually go about creating their own let's say VR or AR project, or start implementing the VFX stuff you might learn on today's workshop? Well, you have an idea and you bring this idea into a creation engine like Unity. That's where you develop it, you work on it, optimize it, and once it's all been designed and developed, you then use an SDK to push it out to any headset or device that you want it available for. So it could be the Quests, it could be the HTCs, could be the HoloLens, the HP headsets are wonderful as well. Really, you take your idea, you build it in Unity, and then you push it out to a store or device that you would like to have it for. Now, today is an introduction to Unity Vfx Graph. So with this, I'm going to take this time to invite my colleague Tyrell onto the stage here. And as he's making his way, there he is. I'm going to share 2 more videos here just to get you all a little more familiar with VFX graphs and Unity, as well as some use cases, use cases of VFX, as well as a demo reel, really to just hype you all up. So I'm going to go over to this one. This won't be as crisp as the other videos I shared, because this one will start right in the middle, But I have another video I'm going to share after this. This will be about 40 seconds, and then we've got another one later on I do want to share with you all. Beautiful. So that was that video, and then I'm going to toss in one more. Thanks for letting me know, Dayon. That one was a little tough to hear and see, but this one is going to be a lot crisper. This is the hype video, and then Tyrell, you can take it away after this. So I'm going to share this one, and then take it away. So here it goes.
Cool.
Yeah, I thought that was awesome. But thanks again for joining us, Tyrell. It's really a pleasure and an honor to have you here hosting this workshop again. You're all in great hands. Again, Tyrell's going to take about 30 to 45 minutes, really diving into this stuff with you all, showing you how it works and getting started with it. So enjoy, everyone. Tyrell, take it away. Thanks again. Really appreciate it.
No worries. So I assume you can hear me well still. Then hello. So as Steph introduced, my name is Tyrell, and I have in fact actually been working in VFX. When I got into the industry, wasn't planning on becoming a VFX artist, and then once I started to get in, realized how close it was to my world of shaders. For any one of you guys who have seen my shader workshop, it can be very mathy and very visually appealing, very visually stunning. It's pretty incredible working at a studio when you are like the lowest tier, the brand new kind of kid right out of college who didn't actually finish college, but you're there at a full-time job with everybody else. Maybe people are looking, maybe they're not, you don't know, and maybe you're taking a lot of time on an effect, but when they come by your desk and they see that, it's oohs and ahs and eyes wide open, and it's, oh my goodness, you've made our game look so much better, this, that, and the other. It's pretty incredible. There isn't too many jobs that pay you to sit around looking at YouTube tutorials and just tweaking values for 4 or 5 hours until you find something that looks really cool. But VFX artist is one of those jobs. So with that introduction, I would like to say as well, like I mentioned, we get paid to watch tutorials all the time. So what that means is as I go through and explain some of these things to you, and show you the VFX graph and show you how to create some effects, it's not meant for you to be able to just walk away and go and create any any new effect by yourself from scratch right away. It's going to be this is more about introducing you to the fundamentals, showing you how someone would build an effect, getting you used to the different components inside the effects and how they work, so that when you do go to follow more tutorials or when you do look up other things, you can get an idea of how they work. One of the really cool things is I worked in the industry on one of the biggest entertainment franchises there is that's ever been created, which uses a lot of, we'll say, magic effects. And that was in Unreal for about 1.5 years. And what's been really cool is the VFX graph is so close to what Unreal has with Niagara, a way to completely script your VFX in a node-based editor, very modular, powered by the GPU, so super powerful, and it's really cool. So cool and so similar that you can even look up Niagara Unreal tutorials and apply them to Unity once you get these base fundamentals that we're about to show you and you understand how particle systems work. So speaking of such, let's go ahead and share the screen so you guys can see what on earth it is I'm talking about. And let's turn on pointer focus so you can see my mouse. 12, there we go. Okay, so I'm in a brand new project. This is Unity 2020.2.1 with the URP. So the VFX Graph only works in URP or HDRP. Those are the new render pipelines. And I'm in a blank project. The only thing I've done is I've made the floor a little bit bigger. And I have already gone ahead and installed the VFX package. So if we go to Package Manager and select Unity Registry, you can scroll down until you see Visual Effects Graph, and I've installed that already. That's it, nothing else. So everything is from complete scratch. We won't even have to worry about importing textures for this. So I want to start off nice and simple, a nice simple system that will allow us to just get our hands dirty with the VFX Graph so we can actually just see what the different components are and how they actually work. So we're going to create a snow shader, a little shader that's going to, or sorry, shader. I'm so used to shaders. We're going to create a snow effect, a snow graph, a snow visual effects graph. And we're going to start there, and it's going to be pretty cool. So first of all, we want to be clean in our project window. So I'm going to come down to the project window. I'm going to right click and create a new folder, and I'm going to call this VFX. And I'm going to go into that folder, and I'm going to create my VFX there. So once you've downloaded the visual effects package, you will have an extra little option right here, visual effects, under the create menu, where you can create a visual effects graph. So that's what I'm going to do. And I'm going to call this one snow. And we can just drag and drop it into the scene like that. And there we go. We already have ourselves a visual effects. I'm just going to drag it out of the example assets. So it's up top here. And we got ourselves kind of a weird looking thing. So how do we edit this? Well, first we can double click on the visual effects graph, or on the visual effect right here from the project window, kind of like an animation to launch the animation window. And I'm actually going to dock this with the hierarchy, and then I'm going to switch my layout to a tall layout like this. Okay, and I'm going to open this back up again. I'm going to put this here. I'm going to put this down here. Put this over here if I can move it. Thank you very much. There we go. Just to give ourselves a little bit of space. So I have a nice big scene view to preview what's going on right here. And I have my VFX graph in the middle, and I still have my inspector, which is going to be helpful. And we can always get back to our old layout. So we got ourselves a system. So what is going on here? Well, this is the VFX graph, and here are the different components of it. It's actually kind of very similar to a script. If you guys are familiar with C# scripting, how you have a start function and an update function. Well, in a VFX graph, you kind of have your spawn function that controls how many particles get spawned into the system. You have your initialize, which is kind of like your start function, where you can set a bunch of initial values, set the lifetime of the particle, set the initial velocity, or give it a position to start. Then you have the update loop, where we can add things that happen to each particle over time. So this is going to be a really fun section where we'll be able to add a lot of forces to our particle and really make them move around. And the next one is the output, which is kind of like just controlling some of the output parameters, the texture, the material, the color, the size, stuff like that of our particle system. So breaking it down, how would we go about creating a snow system? Well, let's look at each section one by one. So first of all, if we want snow, we are going to want a constant spawn rate, and you can see this is 16. So right now, this is going to try and spawn 16 particles per second, but it's actually capped a little bit. It's capped by this capacity right down here. If any of you are familiar with the old Unity particle system, you'll notice this one I find is a lot easier to read. The old Unity particle system just had like a million parameters that you had to look through to try and figure out what to do. This one's pretty simple. There's 16 particles per second and a capacity of 32. I usually like to add more particles, right? 1600 or something, but you'll notice nothing really changes here. I'm also going to turn off the gizmos. Nothing really changes here. And that's because we're capped at 32. So I like to be reasonable, not go too over the top. I don't want to exaggerate it too much, but I like to just kind of go here and add, I don't know, 5, 6 zeros and just turn it to like 320 million for my maximum amount of particles. So, oh, okay, maybe one too many zeros. All right, fine. All right, fine. We can't have that much fun. There we go. 300, only a casual 320 million. Excuse me, Unity. Well, now you'll notice we have something much closer to 1600 particles per second being shot out here. So this is a big difference. So with the old Unity particle system, particles were very expensive because they ran on the CPU. They were known as CPU particles. These are GPU particles. And my friends, with GPU particles, oh, the limits. The limits are, what are limits? 16,000? No problem. 160,000 per second? Sure, we can do it. No problem. Well, a little problem. It's a little, well, that still works. So GPU particles, fantastic. You can do some incredible things with GPU particles. But still, 1600 isn't going to break a sweat for our glorious GPU here. Okay. So we're spawning a whole bunch of particles. That's great. What else do we have? Well, we have this velocity right here. You can see that the velocity is being set. So in the initial system, we have this velocity block, which is setting the velocity to a random value of, so velocity can randomly be between negative 0.3 in x and positive 0.3 in x, negative 0.3 in y, and positive 0.3 in y. So let's see what happens when we change this. If I change this to 0 and 0 in x, now, when it recompiles, now you'll notice there's no particles going in the x direction anymore. Let's focus up on the system. If I click on Snow F, there's no particles going left and right anymore of the particle system. It's only going left and right evenly in Z. If I set this to 0 to 0.3, now it's not going in the negative direction anymore. So you can kind of see what it's doing. If I set this to be completely 0, now it's randomly giving each particle a velocity between 0.2 and 1. So we can already start to control the shape of our particle system from here. In fact, for this snow, I'm not going to use velocity at all. So I'm just going to delete this. And now none of my particles have a velocity. The next one here is lifetime. We can set the lifetime. Right now it's between 1 and 0.3. We're not really going to notice much of a difference while the system is so small in one position like this. So let's leave this for a second and let's talk about position. A snow system is going to need to cover our entire head, right? It's going to need to be in the sky. So first of all, it's still Unity, so it's still like a regular thing. I can click on this guy and drag him up. And let's drag him into the sky. So it's a little bit more as you would expect from a snow system. But then we want to change, we want to set like an initial position. Right now, everybody spawned in the exact same spot. But how about we spawn them in kind of a box, in like a big area? So to do that, what we can do inside this initialized particle, if our mouse hovered over this block, we can just hit the space bar. And now we can add a new block to this. So we want to add a position block. You can see the different types of positions we can set. We can set it to spawn in a box location, a circle location, a cone, a line, a mesh, a sphere. The mesh is pretty cool because that's where you can connect it up to like a, you can connect it up to any sort of model you want. So particles can spawn from a model or spawn from a character that you have perhaps. We're going to be nice and simple, spawn from box. And there you go. My particles are definitely spawning in a box right now. So let's open up this box and we can see the center is 0, 0. Let's change the size to something a little bit bigger, something like maybe 10 by 10 in X and Y. There we go. That's kind of covering my whole space here. And maybe a little bit thinner of a box in Y, 0.5. So it's a bit of a thin line. So they all start roughly at the same spot. Very nice. And now we need these guys to drop. So how would you make something drop in kind of regular Unity? You do that in the update, right? We want to add a certain amount of force. We want to do something to the particle every single frame. This is what's really cool about the VFX graph is we get to kind of control what each particle is doing. So we can do that by coming to this update function right here. And I can just, again, hit the space bar to add a block. And I can go into the forces and I can look for the gravity. And so I can just click gravity and boom, all my particles are now falling. Falling. They're falling pretty fast. For a snow shader, I think I want something a little bit more subtle. So we can set this to like -1. Yeah, nice subtle fall. That looks good. Can also pull this up. Nice subtle fall. Maybe we want to adjust the lifetime a little bit. So maybe we can change this. You'll notice now that this is the lifetime. It's set to the particles are going to live anywhere between 1 to 3 seconds. So if I set this to 0.2 and 0.2, then all of them are only going to live for 0.2 seconds. Whereas if I set this to 20 and 20, they're going to live for a long time, and they're just going to keep falling and falling and falling and falling and falling. So that's it's a little bit weird, but we can actually control the distance or the length with the lifetime, because the longer it lives, well, the longer it's going to fall. So it kind of gives this little weird thing where if we set this to 2 and 2, kind of like that, so they only live for 2 seconds. Okay, that's not enough. So we're kind of controlling the distance from here. And this is particle systems at its finest, where we just set values. And this is what I really like about Unity's particle system compared to Unreal's, is it's very dynamic to make changes here and see them right away, whereas Unreal has a lot more compiling and it takes a lot longer to see things in real time. But we can just set it to 4.4, see how that goes. And that's, yeah, that's not bad. Right about there seems good. So you'll notice we get this weird thing right now where if I look to the left or right, it kind of cuts it out and it disappears. So how do we control that? That is going to be with the bounds. So if I go to the bounds and I increase these bounds to something just a little bit larger, 300, 200, 200, now I can look to the left and look to the right, and it doesn't kill the rendering. So it's just a little bit you don't want to set this too high. The bigger it is, the more performance it's going to take. But this just keeps your render bounds a little bit bigger so that you can see it when you go to wider extents with your camera. But you'll want to play with that to get a accurate size for the entire size of your simulation. But let's, this doesn't look very much like snow, so let's start to change that in the output settings. So now we can scroll down and we can just change this particle to something a little bit more snow-like. So the default particle is actually going to work wonders for us. Not this default particle, but if we click on the little texture icon there and just type DEFA for default, this default particle right here comes installed by Unity by default. And there we go. We're a lot closer to snow already. But you'll notice these guys have a little bit of a black outline. So that's actually coming from this alpha right here, the blend mode. The blend mode of this particle, the shader that it's using, isn't blending out the black color in the alpha properly. So if we just change it to additive, we won't get any dark colors because all the blending mode will only add colors, for any of you familiar with Photoshop. This is a little bit much. I mean, it's getting a little late in the year to be snowing this much. So maybe we'll change it to 160. That's a little bit more reasonable, even though it's a little less fun. And that's already looking pretty good. We could still do a couple extra things here before we move on to another one, like playing with the size here. So right now, each one of them is the exact same size. So let's see if we can randomize that a little bit. So if I go set size, so again, I'm just hitting space. I'm just coming to the output and hitting spacebar with my mouse hovered over it. And then I'm looking for a size value. You see, it's still not the greatest UX yet. So if I type in size, there's a whole bunch of them here. But I can just look for something more specific, like set size. And there we go, set size, attribute set. And there we go. But you'll notice this, again, isn't doing anything. I set this to 14, and it doesn't seem to change it. That's because there's another set size right here that's overriding it. So I could turn this off like that, and there we go. My particles are most certainly 14 in scale. We could tone that down a little bit. But I actually like this size over lifetime, where you can see that it has a curve that increases the size over life. So I'm going to keep this on, but I'm going to click on it. And in my inspector, instead of the composition mode being set to overwrite, where it overwrites the size, I'm going to set it to multiply, where it multiplies this curve against the size. So even if we set these to 3, they're still going to start out small and grow. So they still have this kind of behavior to them, but it's not overriding it. So let's just do something simple here. Let's go 0.5. And let's also click on the set size, and we can just turn on random because random adds variation for us. And so there we go. Some of them are 0.5, some of them are 1. And we got a nice little snow shader, just like that. So this was a quick intro to, there's not over yet. This was a quick intro to the VFX graph in its kind of most basic sense. But now I want to get into something a little bit more advanced. One of the coolest things, the absolute coolest things about the VFX graph is just how modular it is and how much you can script off of it. Because if you guys have noticed, each one of these inputs here has a little dot next to them. That's because this entire thing can be scripted and can be changed into a graph with node editors. So every one of these parameters, you can actually write code, or you can set up a node graph to drive that parameter. So you could have the color, you could have this color set by the position over speed over blah, blah, blah. You get a whole bunch of things, which you probably don't know what I mean right now. So let's show you. So I'm going to create another effect. So I'm going to right click, and I'm going to call this effect just a general kind of, I don't know, we'll call this player interaction effect. We'll call this interactive particle. We're saying interactive particle. What's that? I thought particle systems were just kind of these static things that you create in these graphs. So how do we make them dynamic or interactive? Well, let me show you. So I'm going to open this guy up. I'm also going to drag and drop this effect into the scene like that. So we have our base particle system once again. And this time, what I'm going to do is, well, first of all, let's turn off our snow shader because it's a little distracting, even though the snow is very nice. And let's start playing with this. So first of all, I'm just going to set this up how I want. So first of all, you know me, I like multiple particles. So I'm going to add a bunch of zeros to my capacity. And then I'm going to set this to 16,000 particles, maybe. So a whole bunch of particles. And let's also right away, let's get rid of this kind of weird texture, and let's set this to the default particle right away so we get nice dots. And also let's set the blend mode again to additive, so they are white dots. And oh my god, the bloom so much. Okay, we'll fix that. So right now, since it's additive, it's adding on top of each other. And since we're in URP, we have post-process and bloom by default, which is super cool. So we can already create effects like the sun. So what I want to do is, again, I want to turn off the initial velocity, so they don't really go anywhere. Now they're all just standing right in the middle. In fact, I can just delete that. I can also add a position again. We're going to go back to our box position. Actually, it'd be easier if I type in box. So I'm going to set a box shape. Let's set it, let's give it a decent size of maybe 3 by 3. And maybe, what do we want to go with the size? Maybe 0.2 in the Y. Okay, cool. So I have a box of particles. They are quite bright and hot right now. Let's set their size to be a little bit smaller so we can see them as individual dots a little bit more. So I'm going to come down here and I'm going to go set size again. And let's randomize it. Oh, sorry, that was the wrong one. I want this size to be randomized. And we can go, I don't know, random between 0.1 and 0.3. And this isn't doing anything. Why? Because we have the set over lifetime, which is still overriding. So we want to multiply this guy. There we go. That's a little bit cooler. So now we have a field of dots. All right. So what is this crazy guy doing? What is he going to do with a field of dots? How is he going to make a field of dots interesting? Well, let's see. Let's find out. I don't know. You tell me. First, let's increase their lifetime a little bit more. And let's play with this update a little bit more. So last time we added a gravity force, but gravity is boring. Everybody's seeing gravity. Let me give you something that you haven't seen before. Let's go to force. And let's go to turbulence. Now let's look at that. That's what I'm talking about. We got ourselves some very noisy, randomly moving particles. Now, I can look at this turbulence and I can increase the intensity of it, so we can make it a lot stronger, a lot less. We can change the roughness and, the octaves. We can change like the type, the frequency. We can make it a lot higher frequency, a lot lower frequency. Can do a bunch of things with it. I'm going to keep it simple. But one thing I do want to do is you'll notice this noise field right now is very static, right? It's like every particle is going into this. You can like see the shape of the noise, right? So even though this is cool, I want to just make it a little bit more dynamic. And the easiest way to do that is to start to introduce our ability to script. So you can see if I look at the field transform, so the field, this is the transform, this is the actual noise field. So the noise right now is generated is a 3D noise field. So it actually has like position and rotation and stuff like that. You can think of just a box of values, a box of noisy values. And if the particle is in that position, it's going to get that noise value. So we can open up the field transform, open up the position, and we can actually move the noise. So you can see I can actually move this noise pattern, and I can just adjust it over and over and over again. So what I want to do is I want to make this dynamic. So I'm going to drag off of this X value. If I can, no, come on. There we go. I'm going to drag off of this X value. I'm just going to type in time. I'm just going to put total time in here. There we go. So now I just have a value that's just increasing forever, essentially. And that's just going to make my noise field actually move and make it a little bit more dynamic, which is a little cooler. But now I want to do something really cool. I want to make it so that the player can interact with this, make it look like you're a player character that's walking around is actually able to interact with the particle system around it. So this could be used for something like leaves, for a character walking through a pile of leaves, or like dust or smoke. I really wanted to do a smoke, but it would take a little bit long to create a sprite sheet animation, because that's how you get smoke to look really good. But I've done that before in that AAA studio of creating kind of like a low-lying fog on the ground. And as the player walks through it, it kind of looks very dynamic as he walks through it and moves away. So how do we do that? Well, first of all, let's set the intensity to 0. Yeah, let's set the intensity to 0, so it's not moving at all. And let's start scripting something out. Let's start playing with something. So first thing I want to do is let's explain what's going to happen. Essentially, what we're going to do is we're going to get the position of the player. So if the player is right here, we're going to get the distance. Every single particle is going to get the distance it is away from the player, and it's going to compare that distance. So we're going to get the player's position, the particle's position, and we're going to say, how far away is this? Like how big is this distance? Like this. How big is this distance? And that's supposed to be a D. And if it's well, we'll get how big the distance is, and we'll clamp it to a maximum value. So we'll have like a radius like this around that the player can affect, maybe a size of 1 meter. So we'll have a 1 meter distance, and we'll basically say, we'll take this distance and we'll change it to a 0 to 1 value, so that it's called normalizing. So once we get the distance, we can just divide it by this max range right here, and that will normalize it and put into a range where anything at the edge will have a value of 1, and anything at the player will have a value of 0. And so now we'll have this 0 to 1 value for every particle the farther away it is from the player's position. With that 0 to 1 value, we can flip it around with a 1 minus, make it a 1 to 0 value. And now we can use that to drive the intensity of the noise. Ooh. So let's do that. So we got ourselves a node graph right here. So I can just, anywhere inside here, I can just right click, create node, and then I can type get position. So we just want to get the position of the particle like that. And then how do we get the player's position into here? Well, we need to create a parameter. So to create a parameter, just like the shader graph, we go to the blackboard and we add a vector. So if I add a vector 3, we'll call this player pos, like that. We now have the player's position, so I can drag this on. And so how do we get so we have 2 values. We have the particle's position, we have the player's position. How do we get the distance between them? That's just a little bit of math. To get the distance between 2 vectors, you subtract them from each other, which gets the difference vector. And then you can get the magnitude of that difference vector, which is just the length. So just like that. So we subtract our two positions and we get the length. And now we want to divide it by our interaction size. So we said we want a radius of 1. So this will put whatever that distance is into a range of 1 meter for us, like that. I mean, dividing by 1 isn't going to do anything, but we could set this to, like, 80 centimeters or 2, so we can make this dynamic. We can even make that a variable. And then I just want to clamp it. So that's between 0 to 1. So if there's any value that's below 0, we just clamp it to 0. Any value that's above 1, like 2 or something weird, it's clamped to 1. So now we just have a 0 to 1 range. And now I just want to flip it. So right now it's going to be 1 if it's close to 1 meter away, and 0 if it's close to the player. So I want to flip that range around. So it's going to be 1 when it's close to the player and 0 when it's far away. So to flip it around, we can just go 1 minus, because 1 minus is 0 to 1 value, flips it around if you walk through that math. And there we go. With this, we can use this to drive an intensity. So let's see. If we use this to drive the intensity of our noise field, so right now this is going to be a 0 to 1 value, as it's going to be 1 when it's close to the player, 0 when it's away. So if we multiply this by 10, so it's 10 when it's close to the player and 0 when it's far away, we get this. So right now, in the center of the system, at position 0, 0, we have a lot of noise going on. And I can move this around. So as this simulates as the player's moving, it can move through the field, and look at that. So now we can kind of control and drive this value in real time. So let's do that really quickly. So if I save this, I'm just going to really quickly add a script that allows me to move. So if I add a capsule in here like this, this is going to be my makeshift player. Boom, boom. We'll make him a little bit smaller and taller like this. Spin them around. Okay, so we got our little player right here. And let's really quickly just create a script to control him. So if I go C# script, and I just call this simple movement. And inside update, I'm just going to write this super quickly. I'm just going to go, hey, if you press the input, this is an A C# lesson, so I just want to do this really quickly for you guys. So if input.getKey is the W key, then I just want to go transform.position plus equals, we want to go forward, so transform.forward. We want to multiply by a speed of 3, hard coding that, and we want to make it frame rate independent, so time.delta time. I can hit Control D 3 times, change that to S, change that to D, change that to A, change that to negative, and that to negative, and this to right, and this to right. Okay, so really quickly, we now have the ability to walk forward and back. I'm just going to put the game view down here. So how do we set values from C# into our VFX graph? So if I want to set a value, all I need is the player, all I need is the name of that value. So if I have the name of that value, which right here is player pos, then just like anything else, this VFX graph works just like they usually do in Unity. Sorry, where is my player interactive system? It fell in here somewhere. Where did my, oh, it's called interactive, right? I forgot. So yeah, here is the system. It's just a mono behavior like anything else. So let's try to get a reference to it. One thing you have to know is in order to create a reference to a particle system with this new VFX system, you have to add the using statement using Unity engine.v.vfx like that. So if we add that, now we can add a public visual effects reference, and we can call this interactive system like that. And now on update, all we want to do is we want to set that position, right? So I'm going to set that position by going interactive system.setVector3, and we can pass in the name of the parameter that we want to set on that particle system, which is player pos, and we can pass in the actual value we want to set. So in this case, I want to set my own position, transform position. There's one little catch though. If you noticed, this particle system, this isn't 0, 0 in the world. This is 0, 0 in local space. So the player position, it expects this player position to be in local space. Really quick way to make something local space is just pass in the position you want, which is in world space, and subtract it from the root of the system you want it to be. Oh, let me say that better. So if this is the object that we want it to be in, we want it to be local to this interactive transform. This is the transform that's at, this position in the world. We want a position to be local to him, kind of like as if it was a child. All we have to do is subtract whatever position we want from this guy's position. So if we subtract our player's position from this guy's position, then it will give us a local position to him. You can think of that because you can understand that by if we had a player position that was the exact same place as this guy's position is, if we subtract both of them, we get 0, 0, which would be the position in local space for this guy. So I'm just going to subtract interactive system.transform.position, and we're just setting this every single frame. And now let's see, we can go to our capsule. We can add the, go to our capsule, we can add our script to it, and then we can drag and drop the visual effect onto it. And so now, I have some compiler errors. Where's my console? I don't have my console anymore. Add a, it's not there. Window, where's my console? General, console. There we go. Oh, missing a semicolon. Missing a semicolon, of course. See, even people with 7 years of programming experience miss semicolons sometimes. See, no shame needed. No shame needed. We have a wonderful little console to yell at us every time we make a mistake and tell us exactly what mistake it is we made. Why can't I move you? There we go. So now if we hit play, wait for it to load. And VFX player pos. Did I set the name wrong? Let's make sure we whoops. Oh no, I didn't save player pos. Save that. Make sure we copy this name correctly. There you go. I don't think the particle system was saved. Make sure you save your particle systems. Boom. And names not found. Value of name player pos not found. Uh-oh. Why does it not want to find my player pos position? Exposed. This is saved. Boo. Hierarchy. Let's go to our interactive system and player pos vector. Make sure it's exposed. Capsule. Interactive. Yeah, we got the reference to the right system. Let's remove that. Clear. Add it back again. Simple movement. Like that. Interactive system. It's called player pos. It is exposed like this. We can set it there. And now update. Somebody is not compiling set vector 3 unless if I create a why does it not want to cooperate? It's because I made this a vector. Because I made this a vector instead of a vector 3. Tricky. All right, they want to be tricky. We can be tricky. Sometimes people want to be tricky, and you just gotta play along. You gotta play their game. You are in their world, so you comply. But Luckily, once again, we have a nice console to yell at us the exact error that we were facing. So now we should be able to set our position. There we go. And as we walk around, we are interacting with our little system here. Very nice. One thing we can do is we can do some more things with that interaction. We could use something like we can add another thing to it, like a velocity. Add velocity in a spherical direction, perhaps. Move these down. And if we add a velocity in a spherical direction, it's going to ask for a position to launch them from. Hold on, set the speed to 0. It's going to ask a position to launch them from. So of course we can launch it from player's position. And it's going to ask for a speed. So if I set this, you can see how powerful it is. If I set it even to 0.6 or 0.5, it just explodes out. So let's add a modifier to that again. So if I go multiply, so again, with our 0 to 1 value, I can multiply it by 0.1 maybe, and put that into speed. And now anything around the player gets shot out as well. You can make this a little smaller, 0.5. Save that and run it. Boo, wait for it to load. Oh, 0.5 is too small. 0.5 is too small. 0.1, oh, sorry. Let's go 0.9. There we go. And now we're really just kicking them away like that. And so, yeah, this can be a really cool system for doing anything of the sort of like, if you want to interact with leaves or wind or any sort of foggy smoke, can be really cool to make it look like the particles are interacting with your player as you kind of kick them up and move them around and play with these settings. I mean, we can even have a little bit more fun with this and go set color. And if we again set this color over life to be a multiply instead of an overwrite, now we can set the color here to whatever we want. So let's set it to something fun, like our all too famous lerp node. So if I lerp, again, we have a 0 to 1 value right here. So 0 to 1 value, we can use it to drive a whole bunch of things. So I can use it to drive my lerp, where a lerp is just as simple as you have a 0 to 1 value, and if the value is 0, it passes in the first color or the first value. Or outputs the first value. If the value is 1, it outputs the second value. So if I make this some sort of emissive red like that, and I make the other one some sort of emissive blue like this, we can have all the particles around us be a really hot blue like this. And so now we can kick up blue particles because again, this 0 to 1 value is driving it with the lerp node. If the value is 0, it gives us red. If the value is 1, it gives us blue, and anything in between into the color. And now we can walk around and kick these guys up and around, and things are starting to look pretty crazy indeed. So yeah, I really wanted to show you guys an interactive system, but let me really quickly, I think I can do this in about a couple minutes here. I want to introduce you to one more really cool system that you can use that's a little bit more practical. This one's a little bit more general and just showing you the functionality of how to pass in values into a particle system and how to use that to drive some interactions that's going on. I want to show you guys a more practical system that you can use, like an actual effect. So let's create a lightning effect. So if I create a new VFX, visual effects graph, we call this a lightning like this. Let's turn off our interactive effect like that and drag in lightning like so. Put this over here and let's go into the effect. And okay, so what we want to do is we kind of want to get rid of this. We're done with this standard outputting system. We want something much cooler. So what I want to use instead of this guy is I'm going to delete that. I'm going to create a new node. This time I'm going to go to System, and I'm going to select the simple head and trails. And already you can call it a day because people are going to walk by your office and going to go, wow, that's so cool. And this is the part where you drop the mic and walk out. But we want to change this. We want to do something a little bit different than that. So first of all, get rid of the spawn rate this time. We don't want a spawn rate. This time we want a spawn burst. So I'm going to change this to burst. I'm going to change it to single. And I just want one burst. We probably can't see it. It's probably underground right now. The other thing, since it's a single, it played once and it's not going to play again. So what we can do is we can click on it, and then we can click on this target game object button, and should be able to, it doesn't want me to attach it, but we can play it from here. There we go. So I can replay it. So now we can replay it as many times as we want in order to see what it's doing. So let's start setting some values on here. So again, this time I do want a velocity, but I don't want it to be random. So I can click on here, get rid of random. Oh, sorry, get rid of random, turn random off. So it's always going to have a velocity straight downwards. Let's go nice and fast. These values I tested before, so I know -23 is roughly going to be what we want. Oh, there we go. I can attach it now. So select, so I can replay it from here. So now it's just going straight down. So let's raise it up. So I'm going to go set position. I'm just going to just set the position. Set the position to a nice high value of 5, like that. Replay it. Boom, boom, boom. Very nice. Even though that color is cool, it can sample a random color from a gradient. That's a pretty cool node. I actually don't want that. I just want a regular set color, and I'm going to use this color everywhere. So I'm going to create a variable for it. So I'm going to create a variable color like this. We'll call this the main color. We'll set this to a very strong blue, something like 23 and 180. Nice and strong emissive blue. So if I throw that in there, there we go, shooting down like that. We can set the lifetime a little bit smaller. So I do want to show you what's going on here, because it might not be clear as to, wait, why is this spawning in a line? Why did we get a line all of a sudden? It's because we have two systems right here. This is known as a head and trail kind of setup, where you have one system that's driving the head and the direction of the effect, and another system that's responsible for rendering a trail behind it. And so what we actually have, you'll notice we don't have an output right here. So if I bring my regular output quad, we should be able to see, you can see the little dot right now. Might be hard to see, so you can slow down the play rate to like 12. And you can see that's our little dot right there. That's our particle system that we're controlling with this one. We actually want to get rid of turbulence because we don't want any turbulence. We want it to go straight down and last for 0.25 in lifetime, just like that. And so what it's doing is on update, every single frame, it's going to spawn, it's going to send out an event to spawn 30 of these guys, which this guy is going to listen to. And so we're actually spawning these particle strips from this particle system. So wherever this particle system goes, it's going to spawn a trail behind it. So this is a really cool setup and a way to create some cool effects here. So we are going to use this. We actually don't need an output. So I'm going to delete this output for this particle system. We're just going to use the output of the particle strip. And I do want more of them, though. I do want it to send out more events, something like 200, just so we have a little bit more definition in our lightning here. And let's see, we have ourselves a particle system, our strip count. Again, let's increase that so we don't have to worry about running into a cap on the amount of particles it's going to simulate. So we can set that to 500. We can set the lifetime of this to 0.5, so it only lasts, once it spawns, it only lasts for about 0.5 seconds before it disappears. Let's compile and run it just to make sure we are getting our updated values. And then what we want to do, how do we change this? So we got something, oh, right, we're simulating super slow, that's why. There we go, that's more like it. So we got something that kind of looks like it could be lightning, but obviously it's missing that lightning knee part, right? So let's randomize the position. That's kind of all lightning is. So let's go set position on start here, and let's open this up. And we want to keep the Y position. Wherever it is vertically, we want to keep that the same. So I'm going to get position like this. And I'm going to expand that. And I'm just going to make the Y, whatever position it had in Y, keep that. Don't change that. So Y is going to be set to Y. Let's give ourselves a little bit more space here like this. And then let's go ahead and add, let's randomize the X and Z values. So I'm just going to drag off of X. I'm going to say random number. Ooh. Already starting to get something a little bit more lightning-y. So what's happening is the X position is going to be set to a random number between 0 and 1 for every single particle along that ribbon. And that's already giving us kind of an effect we'd like here. I do want to do the same thing for Z, because you'll notice if I go to the other side, it's only, there we go, right about here. You can see we don't see much variation here because it's only going in one direction. So we want to randomize in both directions. So I'm just going to duplicate that node and plug that into Z. There we go. So now in all random horizontal directions, it's getting very spiky in both sides. I also want to make it even on positive and negative. So what we can do is I can create a float variable to control this. So I can call this noise amount, like that. Drag and drop this into here. We can multiply this by -1. And so we get negative noise amount on this side, like this, and positive noise amount on this side. So noise amount is set to 0, but if we set this to 0.2, what are we getting? So we are, let's get some more space so it's not so ugly. More space, no, more space. There we go. So we have our noise amount, which is set to 0.2, and I'm going to set it to -0.2 min, -0.2 min, and then positive 0.2 min, max, positive 0.2 max. I'm just going to set this to a random seed, just so both of these numbers have different random numbers. And there we go. We got ourselves a little bit more lightning, a lightning look. There's a couple more things I would like to add to this, but we do have a happy hour tomorrow. So I think I'll save some of the extra goodies, like adding the sparks and the flashes and stuff like that, and also controlling a little bit more of the size of the lightning effect as well, so that it grows over, it's bigger at the top and smaller at the bottom and can shrink over time. A lot of fun stuff we can do by scripting this out. But I don't want to take too much time here, and we are running another happy hour tomorrow on YouTube live stream. So I also want to save myself some fun things to do for tomorrow while we hang out and talk some more. So I'm sure you guys have tons of questions, because I kind of just ran through a whole bunch of parameters there, but I really just wanted to give you guys a look of how kind of quickly you can get a lot of really dynamic effects by just playing around with a couple of values, changing some things. And I think this is far more of an approachable, even though it's a much more powerful system, I feel it's much more approachable than Unity's old particle system, which was just kind of a blech of values and whatnot. Where this one's sectioned out, I think, a little bit more nicer and is a little bit cleaner to see. So I guess with that, I can I can invite Steph back on, but if he isn't here just yet, then I will definitely keep going. No, you don't have to tell me twice. Okay, there he is.
Surprise, I'm back. Hey, Tyrell, my man, thank you so much for taking the time to show all of this stuff. Super excited for that happy hour that you'll be hosting tomorrow. I'll tell you all more about it. My colleague Dayon did just share it in the chat as well. So feel free to join us tomorrow. I think it's at 2 p.m. Pacific time, if I'm not mistaken. But either way, that'll be a fun one. So before I wrap things up in the next 5 minutes and we open it up for the Q&A session, I'm going to toss in a poll here asking you all, on a scale of 0 to 10, how likely are you to recommend this workshop to others? 0, you wouldn't tell anyone about it. You wouldn't recommend it. 10 being you would recommend it to others. So I'm going to toss that poll into the polls tab here. Please do let us know. It helps us know whether we should continue hosting these workshops or not. Bring in Tyrell to feature some other things. Really, really does help us out. So please do let us know. With that, I'm going to share my screen here, take 5 minutes to wrap things up. So let me pull it up. Wonderful. Thank you, Tyrell. So again, tomorrow, 2 p.m. Pacific time, 5 Eastern, if I'm not mistaken, happy hour with Tyrell. So a discussion on AR, VR, mixed reality, really anything, any questions you all have that you want to ask Tyrell, show you some things, join us. It'll be held on YouTube. It's all live. So really exciting stuff, and I'm looking forward to being a part of that tomorrow as well. But as I mentioned, you know, if you are looking to take this to the next level and learn how to create something yourself, and you're more so of a beginner, a 1, 2, let's say 3 out of 10 in Unity, we'd love to have you with us in one of our courses, which Tyrell leads as well. We have our beginner intermediate friendly XR developments with Unity course, 10 weeks long, 4 hours per week. 3 of those hours are in class, 1 hour private session where you can meet with a mentor like Tyrell to work on your projects and get support developing it over the time with us. Covers Unity, VR, and AR foundations, C# as well, because that's what Unity uses, as we've seen today. And again, weekly one-on-one project support with our team like Tyrell. So the full price of our course is $39.50, but we are offering a starter pack for everyone who's looking to get into it. It includes this 10-week course, a 3-week C# scripting course, and an Oculus Quest 2 headset. You can add on to that for our starter pack plus with an intro to XR design course at 50% off if you're looking to complement and learn more about the design side of things. For this course specifically, no experience required, so newbies, have no fear. We welcome everyone from all walks of life. Now, for those of you who rated yourself higher on Unity and really already confident and familiar with C#, VR and AR development, we have this XR Project Accelerator program. 8 weeks long, 5 hours per week, 3 hours in class, and 2 weekly private sessions to really accelerate and develop the stuff you're already working on or something new that you'd like to advance quickly. So again, this covers more advanced and in-depth features of AR, VR development, design, what to think, some theoretical aspects. And this also comes bundled with weekly private sessions to support and accelerate those projects of yours. Now, the course is $44.50 as well. This comes as an accelerator pack, 3-week C# course if you haven't touched C# in a while and would like to brush up on it, and on Oculus Quest 2 headset as well. And same as this VR starter pack bundle, you can add on our XR design at 50% off. So for these 2 courses, the 10-week and the 8-week, we have a 3-month payment plan, a 6-month payment plan, and a 12-month payment plan for anyone looking to split it up into monthly installments. Now, if you're interested, download our syllabus or apply now at circusstream.com/learning. Myself, my colleague Kyle, or any of our team members would be more than happy to chat with you, see what your idea is about, offer insights, and see if it's something that we can support you with. Now, we do also have private team training opportunities if you have a group of colleagues looking to learn all together and work on a similar project. You can also reach out to us about that if you have any questions around it. Whether it's myself or my colleague Kyle, we're here to help out any way we can. But with that, we're going to wrap it up here, open it up for the Q&A session. I see a lot of great questions in the questions tab. So do let me know. I'm actually going to go by upvotes. So if you see a question that you'd like to have answered very quickly, upvote that question. We'll get it going. But I have one here from Jeff, and this one's for you, Tyrell. Jeff is asking, would Vfx Graphs work on Quest 2 in terms of GPU, CPU workload?
100%, because the Vfx Graph is a GPU-based particle system, which will be far more efficient than any CPU particles. I mean, I was going crazy and adding 16,000 particles per second, but if you did like what you usually do with CPU particles, like only 160 or even 50 or 20, because people have had tons of experience creating particle systems with a lot less particles and figuring out still how to make them good. If you do that with a GPU particle system, you'll be completely fine. So 100% it would work on the Quest 2, and I would highly recommend it to, if you were doing any sort of particle system, I would highly recommend using the Vfx Graph because it will be far more efficient for sure.
Beautiful, thank you. And there was a question, I think, also asking about the GPU side of things, so we'll cover that here shortly. This one's from Aditya, and Aditya is asking, will the amount of particles affect performance on users' devices? This was it, that don't have high-end graphics cards.
100%. The more particles you have, the more performance you lose. But again, the GPU is specialized in doing massively parallelized work, and particles are just that. They are just little dots, little positions, and they're written in a way. In fact, little known fact, all these particle systems that we're writing in the VFX Graph are actually shaders. We're writing what's known as compute shaders. All of this logic and these node graphs are running as a shader program on the GPU. So they are very efficient. So you can go pretty high. Like I'd say anything around 10,000. 10,000 and below, you will be fine. Once you start getting above that, that's when you'll probably start getting into on lower end GPUs. That's when you'll probably start getting into a noticeable frame dip, perhaps, on a lower end GPU. But again, it takes quite a bit of frames to become a problem. And on higher end GPUs, you can still do 40 or 50,000 particles every now and then, no problem. So what I'd say, if you're looking for a number, anything below 10,000, and then if you're below 1,000, you're more than fine.
Interesting. Thanks for the insight there, Tyrell. Hope that helps, Aditya. This one's from Maggie. Maggie's asking, what are some good practices for memory management when using particle effects?
Good practices for memory management when using particle effects. Limit the amount of data you're sending from the CPU to the system, because again, everything on the particle system runs on the GPU. So when I added the player position to the particle system, that's great, but don't get so attached to that you're using that for every single system, or at least don't get so attached to that you're sending massive amounts of data to that particle system, especially things that can be calculated inside, things that can be calculated in the particle system in that node graph. So I would say favor doing the calculations inside the node graph if you can, but if you can't, then send it from C#, which would therefore be sending it from the CPU, which would take more memory management to go back and forth. Other than that, there isn't really much, because in Unity's VFX Graph, I was looking for it a lot last night, but I couldn't find it. In Unreal Niagara, you're able to set variables inside the shader graph, inside Niagara. But I couldn't see a way to actually set any parameters inside the VFX Graph here, which means there really isn't much worry for much memory management that you can mess up inside of here. So I would say low-res textures, because those are also memory things that go to the GPU. So lower res textures and shaders, and limit the amount of stuff you're sending from the CPU.
Beautiful. Hope that helped, Maggie. Do let us know if there's anything else you'd like us, or Tyrell, to cover in this case. Then we've got one from our man, David. David's asking, Tyrell, where do we learn about the theory behind these things? Example, the physics aspects.
The physics aspects. Grade 11 physics class and grade 12 physics class is where I'm getting most of my physics knowledge, and then some university math classes in terms of like the physical theory behind things. Other than that, in terms of practice, where do you really learn it from? Experience. Playing. Again, one of the most incredible things about this system compared to Niagara's, or just in general, is just how open it is. Like when creating these effects, it is a very dynamic of just, all right, here we go, and let's just test numbers. Try it at 20, try it at 30, try it at this size, this speed, this much force, this less force. Like, I don't necessarily, for example, for example, if I go to share screen right here, when looking at these values in the turbulence force, I have an idea of what octaves is, what octaves are. Well, the lacrinarity, I don't know. But what I do know is how to do that, and how to do that, and how to do this and that and that and that, and then how to use my eyes and look and see what effect it has. And for this, I can see that is doing next to nothing. So, okay, I'm not going to worry about lacrinarity for this effect. Well, it's not doing anything here because turbulence isn't really being used, but that's the basic idea of a lot of these things. If you try to understanding it from a true, like actual physics-based understanding is only going to get you so far, because you need to know how it's actually applied in the game engine and how to use that knowledge, or where the game engine drastically simplifies the real world. In many cases, we simulate physical world, but we do so at a far more simplified level in kind of our own way. So knowing the true physics behind things only takes you so far. What's really going to take you far is jumping in, setting up a system, playing with the values, and growing your instincts and growing your intuition for what drag is going to do to an effect, what intensity is going to do to an effect, and what octaves. Like there's no perfect way of making a system. Every system that I've made inside of the studio and watching, I worked with people who've been in the industry for 20 years doing VFX side by side every day. And it's the same process. You sit down there, you have an idea, you kind of set it up in general, and then you play with the values for hours until you dial it into something. So it's really just comes down to growing the experience growing the intuition through experience through playing.
Mm-hmm. And I guess kind of stemming off that question for you, Tyrell, how long did you dabble in this side of things and then picked it up?
I mean, I was in Unity for 3 or 4 years, or 2 or 3 years before I got into the industry in Unreal. And kind of right away, since I was a shader guy, they also kind of had me become the VFX guy as well. And right when I got into the industry is right when Unreal came out with Niagara. They were announcing it at GDC and everything, and it was mind-blowing. It was like, this is so cool. It's just HLSL, compute shaders, and a node graph, and we can completely script everything. We can have the position driven by the color, based off of the size, based off of position. It's like everything is completely modular and scriptable. So it was mind-blowing, and so I just got into it from that point. Tutorials. I mean, I know pretty much all of the YouTube tutorials out there on Unreal. Well, at least a year ago I did, because there weren't that many of them, but we went through every one of them at the studio. We knew CG Howe is a classic guy for Unreal Unity tutorials. He basically should get a credit on our game with the amount we use his tutorials for everything. So it's just diving into it about 2 years ago. Just tutorials, and then playing with it in the at work until you created the effect that they were looking for, that made the producer smile and gave you a good pat on the back.
Right on. Thanks. Perfect. Then we've got another question here from David, and David's asking, do you have to consider these particle effects to the end device? Example, PC versus smartphone. How would you gauge that?
Yeah, 100%. You start playing more with these parameters and having values based off of the hardware. Like on mobile, you might have 100 particles, whereas on PC you might have 2,000. And so you can have different particle systems based off of that. And if you start adding more parameters and more nodes, you can tweak the values and the degree of. You can tweak how much complexity and performance your particle systems have via these parameters, right? Like even all of this can be scripted. This count, which is set to 1, we can drag off of that and create, I can create an integer variable like that. And there we go. I can now control the count from outside in my, I control the count from outside here. So we can set that based off of some C# value, which can control the amount. Or we can have a duplicate system, one set to 2 and one set to 5, and turn the correct one on depending on which one we're at. So I would do that. a lot for gauging it. The other thing is Unity's pretty good with not needing you to have to work, needing you to worry about one of those need configurations to worry about the target device as much, because usual shader programming, you do. When you open up a shader program, you'll see a whole bunch of pragma and hashtag defines and all these things that specify the shader level and the GPU level, because back in the day, different devices, mobile PC, had all different kinds of support levels for the different types of shader compile levels and OpenGL levels, which meant that some features literally just wouldn't work. Like there are some phones that used to not support compute shaders, and some PCs or some Windows 7 or something like that, which wouldn't support OpenGL 4.0, so you can only use 3.0. And so that changes a lot. That used to be a big thing you had to consider, but I would say these days, the vast majority of devices that you're going to be deploying to are going to be supporting of the latest technology, and Unity's been pretty good at making all of this stuff work on pretty much every platform. And it will usually give you a pretty big warning message if something, pretty visible warning message if something is not going to work. But the best answer, the final thing I could say, is test. Test. Always test on your target device and see, rather than worrying about oh, is this going to work? Is this going to work? And spending a whole bunch of research and time looking up the exact amount of particles it can handle. Just test it. Just deploy and see, does 100 work? Nope. Okay, 50 it is. And go from there. Test early and often.
All right, on. Well, I hope that helps, David, and definitely helped me. Thank you, Tyrell. Then we've got one here from Jeff. And Jeff was asking, does Vfx Graph work only in high-definition render pipeline template?
I am in the universal render pipeline, so no. There's here too. High-definition render pipeline has a much cooler one, though, because these outputs, you'll notice, if I go back to the snow shader or something like that, wait a second, that lightning looked very cool. Wait, let me see that again. Oh, it's not as cool anymore. This one?
Ooh, spicy.
Yeah. Okay. So the interactive, see what I mean? The amount of effects I and the partner I was with at the studio created accidentally, it's insane. The amount of things you'll just be typing in numbers to put in a random stupid high value just to see if it's working, and then you create something that looks like a sun, and it's like, oh my goodness, we have the most cool fireball effect ever, even though we are trying to create a soft mist or something like that. And we create a super cool fireball effect. So a lot of fun you can get from just playing around. But the output. So one of the really cool things you can do in HDRP is, right now we've just been outputting quads for our systems. And quads are just going to fall down with these basically planes, but we could output other things too. So we could have this exact same system output meshes. And so now we have a bunch of capsules falling down instead. And we could have all sorts of, it has a weird shader on it right now.
Right.
But so you can see it's kind of wrapped around the capsule in a weird way, but you can have the particle system spawn all kinds of super cool meshes and whatnot. But what's really cool about HDRP is you can spawn lit meshes. So in HDRP, run VFX Graph, you can have meshes that actually respond to the lighting in your world and have get the sun and the shadows. So you can actually have a box that looks like a regular box, but it's a particle system, which means you can maybe break it into all kinds of super cool things and back into a regular looking object. So it's really cool with that one, because effects can really be grounded in the real world if you allow them to be lit. But yeah, this system still works on HDRP or URP.
Right on. Perfect. I hope that helps, Jeff. Do let us know if there's any other questions you have. And then here's one from Jessica, and I tried to answer it in the chat earlier, but I left the question open because I'd hate to give any false information. You're the master here, Tyrell. So
package manager.
Yeah.
Go to window, and so it will only work inside of a URP or HDRP project. But if you go, and of course, any other project that isn't URP or HDRP, you can convert it to URP or HDRP by coming to the package manager and selecting URP or HDRP and selecting install. But assuming one of these are installed, then yes, package manager, Unity registry, and Vfx Graph or visual effects graph, and install, and you will have it. You can also download these samples, which can show you a lot of really cool effects that they have made themselves, probably from that I would bet you some of the effects from the video that Steph was showing earlier would be in some of those default packages.
Oh, cool. Very cool. So yeah, that's for you, Jessica. Again, for if people can't see the question, just wanted to know how to add the VFX graph to a new project, and was curious if it was through the packet manager. So thanks for showing us, Tyrell. Let's see, we've got one here from Antonio, and Antonio is asking, what would be the performance for HoloLens 2? Could it be used in HoloLens family devices?
Yes, because it would, I mean, I would imagine it still could be. Again, test it. But yes, because at the end of the day, this is just a compute shader. As long as the HoloLens can run compute shaders, which I'm pretty sure it can. The only reason I'm hesitating is because I haven't seen it specifically, or I haven't worked with the HoloLens in a while. But technology only gets better. So I would assume by now for sure they would be able to run a compute shader, and if they can, then they can run the VFX graph. That's a good question. I have we have some other people at the studio that know, or at Circuit Stream, that are much more familiar with HoloLens dev than I am. So I'm actually curious to ask them, ask Nikisa's, who I'm thinking of. But I would hazard to guess yes, it would. But again, you will get a very stern message if you try to.
Perfect. Yeah, no, so I've taken this question down, Antonio, as well to loop back with Nikisa, but thanks for the insight. I'm also very curious to know that. Now, this one ties in with Unreal, Tyrell, and this one's from David as well. Is all of this close to competing with Unreal? Can, for instance, he do Mandalorian effects with Unity now?
100%. There's a couple small things missing still, but they're like, you'll have to start getting into some very complex effects before you run into those barriers. I mean, because at the end of the day, you can just script it. So much of the things that you see are built off of these basic systems, and then just manual code of just placing the particle systems where you want them to be placed. If you had a exact description of the effect, I could quickly tell you how it would be done, or if it could be done. But yeah, for the most part, this is what blew my mind as I came into here looking at this and working in Niagara and Unreal for so long. It's like, oh my God, this is like Niagara. I'm like right at home. Like I literally watch Unreal Niagara tutorials to create effects here in the visual effects graph because of how similar it is. So yeah, totally. I would say it is definitely caught up, at least in the visual effects realm, of what it can do. But Niagara is a little bit more experienced, just because it's been out for 3 years now. So they are going to have a little bit more, nicer UI and some extra kind of small features for the extra advanced things. But Unity will catch up there soon enough. But for general, 100%.
Right on. Yeah, I heard that Unity was putting a greater focus on this type of stuff to really, catch up and surpass Unreal. So we'll see how it goes. But yeah, they've got some great stuff going on. Beautiful. Let's see. So this question is from Farzana, and Farzana was asking, can you show if snow hits some stones, flowers, and only those stones, flowers disappear? So
yeah, I saw that question, and I was looking at it, and unfortunately, that's kind of tying on a very you kind of hit the nail on the head of an interesting topic that is actually kind of impossible in any sort of VFX graph. It's the idea of taking information out of the VFX graph. So we can very easily, so remember, as I said, the VFX graph is largely just GPU shaders, running, right? So if we're on the GPU running our VFX graph, we can, on the CPU, we can send information into it, player position and values and changing values and time. And we can send a whole bunch of things into that VFX system. But all the particles that get generated and start spawning and falling and doing things, they can interact with each other. They can collide with things from the CPU world, and they can destroy themselves or move away or trigger more spawning of more particles. But to take information out of the particle system, where, okay, this particle, 527 hits this thing right here, we can do a whole bunch of things here, but to take that information out and actually destroy that thing, which is separate from the GPU particle system, that is just not really possible. You could probably write some super complex thing, but then it would be far from efficient. And I mean, like, you wouldn't be able to do it in the VFX graph. You would have to write the shader code yourself manually to write to buffers, and it would happen a frame later and stuff like that. It would not be an efficient thing at all. So how do you do it then? How do you have a particle system seem like it interacts with a CPU environment? Well, you do, if you had a fireball or something like that, how do you shoot a fireball at somebody and do collision detection on it, and then, tell that enemy that their health should be lower or damage them in some way, right? Because that's all information that resides in the CPU land. You fake it, you trick it, just like us. We didn't really, right? The player wasn't really colliding with the particles. We were just faking it. We were passing in a position that represented kind of where the player was, and we were passing that into the system. So how I would do a fireball, interacting with a player, if I had an enemy here and I had a fireball effect, fire, and we shot it forward at the player, what I would do is there would be a system kind of like that system I was fooling around with before. That's like this big fire system, and it have a velocity this way. But what I would do is I would spawn a sphere in the exact same position as that particle system and a roughly the same size, and I would just make it invisible. So you wouldn't be able to see that sphere, but it would be there, and that would be a regular C# object. And it would have a collider on it, and it would be traveling at the same speed as a particle system. So when the sphere got here, it would say, hey, you've been hit. And then it would send a message to the particle system to destroy itself as well. And so it would appear like the particle system is affecting and hitting that. So that's what I would do. So specifically for your effect, where you said you'd have snow, that would be a little bit tricky because you can't really put a sphere on every one of the snow particles, because otherwise, Why are you using a particle system? You might as well just spawn regular C# spheres. But if you had something a little bit more singular or concrete, or something that could be approximated with a shape of some sort, approximated with a C# collision volume, at least roughly, then you could still make it look like that behavior is happening, even if it's not happening directly.
Beauty. No, great question, Farzana. Great question. So, Tyrell, I know you've got some things happening in the next 20 minutes or so. So let's take another 7 minutes, few questions to answer before we wrap things up here.
All right, do you have questions?
Yeah. So we've got one from Kevin Ang, and Kevin was saying, I was working with VFX Graph in its beta infancy in conjunction with Bolt to create an audio reactive VR experience with Keijiro's skinned mesh renderer. Do you recommend a resource to help update without losing the bells and whistles?
To help update what?
Let's see if he's still kicking around here, Kevin. If you are, give us a shout in the chat. I'll check if he's still online, Mr. Kevin.
So I think I saw a question related to this before, asking about MIDI integration with the VFX graph. And I mean, yeah, because all you need is to parameterize what you mean, right? So if they hit a C note and then they hit a D and then they hit an E, or they if you can parameterize that in C#, which you can, because I actually have a student in our accelerator doing a lot of things with MIDI and audio synthesis inside of Unity. So I know there is a pretty cool plugin for MIDI synthesis. I can't say that word properly. And we're doing a lot of things like creating chords and creating harmonies and creating sequences and whatnot. So if you sequence or if you parameterize all that stuff out, and have values that you could turn on and off and say, okay, this thing happens now, this thing happens now, that thing happens now, then you can pass that stuff in, right? You can pass that stuff into a VFX system. You can have a VFX system to spawn when a major chord is hit, spawn this when a dominant seventh is hit, spawn this when held for this long, or when hit at this velocity, send in this much intensity to the particle system. And as that trails off with the natural decay and this curve, then I want you to trail the color or I want you to trail the color off with the same value or the intensity or the emission amount. So it really just comes down to when tying a particle system to something like a character or like a MIDI input and stuff like that, it just comes down to asking yourself, what are the values you want to tweak? Do you want to tweak the shape, the emission, the color, the speed, the force, the size? Like there's so many things you can tweak inside that particle system. Ask yourself what you want to tweak, and then ask yourself, what do you want it to be based off of? Major, volume, this chord, that chord, and then you can start to connect those up via floats and bools. Essentially, and normalization is essentially how that would work.
Right on. So let's see. Well, let's do another. There's a lot of great questions here, but let's try and squeeze it into 4 minutes. We touched up on the universal pipeline earlier, but this one's from Gwendolyn, and Gwendolyn was asking, the project she's working on is Sharp D, however you would say this project. Can I convert it over to a universal pipeline project to take advantage of the Vfx Graph?
100%. If you have a standard, Unity project that isn't URP or HDRP, to upgrade it, all you have to do is go to the package manager, Unity registry, and then select URP and select install, and that will upgrade your project to a URP project. Once you do that, all of your shaders will more than likely become pink. So to fix that, you just go to Edit, Render Pipeline, Universal Render Pipeline, and Upgrade Project Materials. And that will fix the vast majority of your pink shaders, anybody that was using a standard asset. If there's still a couple of them left, then you can, sometimes the upgrade all doesn't work, and sometimes you have to select them. You have to find that material, find that material in the project window like this, and actually select it like that, and then do the same thing. Edit, Render Pipeline, Universal Render Pipeline, upgrade selected materials this time, and that will fix it. And if it still doesn't fix it, then all you need to do to fix it is just go to that material and change the shader to one of the Universal Render Pipeline ones, because you'll notice from the standard ones, if it's set to standard, it will be pink just like this. And so all you have to do is use one of those auto options or come in here to that shader manually, Universal Render Pipeline, and switch it to the lit version, and you'll be good to go.
Beauty. Hopefully that helps. Then we've got a recent question here from Brent, and Brent was asking, could you scatter the flowers or rocks as particles to have the snow interact with them?
If it's in the same system, then yes. Again, if it's all, so you're starting to think the right way. So it's like, if we can't get information out of the particle system, how can we send more information into the particle system? So as I was showing you, like if we create, there we go. If we create a material, I think it will have to be an unlit material. If we go Universal Render Pipeline, unlit, and we go to, which system is this? Is this our own? Is it this system? Nope. This one. You know what? We will. Which one is that? Okay, well then we'll create a new one. Never mind. That's why you stay organized. Otherwise, you lose your particle systems. And bring this in here like this. Okay, so if we have a regular system, as I was showing you before, we can go into that system and we can actually change the outputs to, instead of outputting a quad, outputting a mesh. And so you can spawn, and then what I want to do is I want to put this material in here. Oh, it has to be a shader graph material. Damn, I didn't create a shader graph, but you can change it to a mesh and we can have it spawn cubes, for example, like this. So you can see a whole bunch of mini cubes, or we can spawn, I mean, if you had a flower, you could spawn the flower. You could spawn hammers, but it's going to be hard to see the hammers with this material on it, and hard to see the shape of that hammer. I doubt we'll be able to see it. Compile. Yeah, we're not going to be able to see it from there. Oh well. Yeah, we can spawn. If you create your own material, you'll be able to spawn rocks and flowers. And I actually did that for my baseball game because I wanted a really dynamic crowd, and I was like, how do I have thousands of meshes up there to represent a crowd, or 1,000 of moving things? And I actually created a particle system for it. So I was able to have in VR, like 4 years ago, back on that level of quality of VR, I was able to have like 12,000 moving and jumping fans in my stadium because it was just a big particle system that was spawning all of them and just doing a little wiggle animation, and just a little bit of motion looks like a stadium rocking. And so, yeah, you could totally start to do a lot of cool things with that. And then, of course, using all of these techniques, I could do things where if I hit the ball into it, or I could do waves. So if the entire crowd could do the waves, put animations into there, and have a sprite sheet that changes the mesh. And so you could have different animations of the mesh. And so now you could have an animated particle system crowd. So you can do a lot of cool things with systems like this, for sure.
Beauty. So we'll wrap it up with one last question here, because I think Robert is still online, and it sounds like he's going to be joining you for the happy hour tomorrow. So it could be a follow-up question for then. But Robert's asking, in advance of tomorrow, have you found any workarounds for the conflict between Vfx Graph and Android? So they've developed a bunch of looks and systems that they just can't use in mobile or on Oculus.
Yeah, so I would say you definitely are going to have to be on a, it's because it's rendering this. That's why both of them are rendering at the same time. You're definitely going to have to be on the newest versions, because when things first came out, they were still experimental, and they weren't going. I'm pretty sure when VFX Graph first came out and things were still experimental, they didn't work on the newest hardware. So Oculus and not that hardware is that new, but they didn't. It just didn't work because of a lot of the shaders that need to be compiled. I'm pretty sure that the VFX Graph now does work on Oculus on the newest of versions, because URP had a lot of problems before on Oculus, whereas URP can work now on Oculus. So I'd imagine with that addition of URP to VFX Graph will now work as well. If it still doesn't, though, because I know Android, URP, and Oculus have definitely had their issues. In fact, I went through them quite a bit last month, diving into a lot of just build issues of trying to get like the maximum performance on a Quest. And unfortunately, there isn't much you can do except wait for them to fix it. You can still try to do a lot more shader stripping to get rid of a lot of the shaders that are not working. But if it's still just not compiling, then unfortunately it's not compiling. And that's kind of on Unity to fix. There is still a lot of things that like make it very finicky of like exactly what Android Studio version you're using, exactly what JDK or JRE and SDK and NDK you have installed, and which one Unity is referencing and building to. There is a lot of settings to go through, but if you have double checked all of them, then I would say you'll have to pay attention to the forums for when those bugs get reported as fixed, essentially.
Beauty. Well, we'll wrap it up there, Tyrell. I know you've got some stuff at the top of the hour here to get to, I believe, if I'm not mistaken. But thank you, everyone, for joining us on this workshop. I knew it was going to be super exciting. I wasn't wrong. Thank you, everyone, for all the great questions, for joining us again on another workshop. Great to see you all rejoin us. Hope to see you on some future workshops. Don't forget, Tyrell's hosting a happy hour tomorrow, 2 p.m. Pacific time, 5 p.m. Eastern. So do join Tyrell tomorrow to chat about anything, whether it's VR, AR, shaders, art, NCAA basketball, see him solve a Rubik's Cube, whatever it may be. Tyrell's there to chat with you all. Again, it's great to have you join us. Tyrell, the man, the myth, the legend. Thank you so much again. It was an honor and a pleasure to have you. But with that, we hope to see you on our workshop next week with Makisa, maybe some of our courses, the happy hour tomorrow. And I wish you all a wonderful day, evening, night, morning, depending on where you live in and if you're still tuned in. But thanks again, everyone, and hope to see you all soon. Take care.
Hey, I got it.
Yeah, the hammers.
The hammers.
That's
All
it.
right. Take care.
Take care, everyone.